Okay, welcome everybody to this session about automate your analysis using tshark. If you have got questions, you can put in the Q&A, and depending on the time, I will answer them in between the sessions or afterwards. My name is André Luyer. I'm doing this session today from my home in the Netherlands. And over the years, I've done a lot of troubleshooting using Wireshark, and before that using Ethereal, and before that even Sniffer Pro. Yes, I'm that old. I'm also a trainer for an in-house Wireshark bootcamp course, and I'm involved in the DDoS testing, so being the red team, basically using all kinds of tools. And if you want to contact me, you can find me at Twitter. You can find me on LinkedIn. And if you want to send me an email, you can look it up in Wireshark under help about authors. Okay. If you have this, okay, that's it. So back to the basic question: why should you automate your analysis, or why would you? Well, in my case, when you do a lot of troubleshooting, you get a lot of similar questions. For instance, you get a question, has been solved right now, yes or no, and then you can do the same analysis again. And then it becomes easier to make some scripts to do the same analysis over and over again. And that's actually how it started with me. I started with handy scripts, and that ended up in a complete tool that users can use for their reporting. And you can also use it for to scan for issues and anomalies. For instance, is the encryption version used outdated or unsafe, especially with security issues. What's safe today may be unsafe tomorrow. So that's cat and mouse race, basically. And you can also trigger on certificates that are about to expire. Another thing is for using for statistics, look for trends and performance issues. For instance, you can look at application turns, you can look at if the overhead is too large or something like that. And it can be a part of an CI pipeline. You see that more often nowadays. Okay. So what we're talking about is about network knowledge plus coding skills. So that's today's topic. But first, let's start at the beginning. I can show you how to zoom in with, how to use tshark like this. Use the option R to read from a file. We can use the option capital Y to enter a display filter like TLS. And I use the option C here to limit the output. And what you can see now, let's make it a bit more trendy. What you can see is that the output is limited. And you can do exactly the same in Wireshark, by the way, by changing tshark into Wireshark. It should open now. And as you can see, it's about the same difference, the view. Like you can see the same headers here as used over here, right? What you also see here, let's go back, is that the output is a bit different. Here it is in relative time, here it is in absolute time. That's because of the setting. You can change that by adding the option T for timeline and say you want to see it in absolute time. Now it will display time in the same way as in Wireshark. So Wireshark and tshark share the same basis, the same core support dissecting. I can show you that using now using a terminal here. Sure. Something popping up. All right. Just a moment. Oh yeah. If you change the layout here, for instance, do like this. Oh, it opens. Let's move it to there. Like this, and you run tshark again. You'll see that it now also has changed here. Oh, zoom out a bit. You see here it is there also. So when you automate things, you get different outputs, and that may be something you don't want to have. The reason for that is over here. It's that using the default profile. Well, a few ways to cover that. You can either change the profile so that you don't change the output of tshark, or you can add to tshark the option C and provide another profile name. And what you see here is that Wireshark is designed for manual analysis, and tshark also. So that is also using the same engine underneath. So what you see is that if you run tshark, let's say demo, and you want to write it to another file and do some filtering, like address, oops, equals, will show the resource running for a while. So when you run it like this, make a typo. G. Sorry. No. Now. Okay, there goes my test and demo. I have to do it on a big file, and we'll see what happens. You'll see now that it is consuming one core. You can see here. Oh. Now, you can see it's using up one core because it's dissecting using a single thread. It's the same way as in Wireshark. And you also see the memory going up quite large. And that's the way it's designed. It's designed like Gons said this morning, to analyze relatively small files. If you do in big files, it takes more time. I'll break it off. So if you change it to TCP dump, for instance, and change the filter into a capture filter, time it, then TCP dump was missing a character. Then you'll sorry, I missed the one. You'll see it runs a lot faster because capture filter works on a packet by packet basis. So it's going a bit fast here. let's leave it like that. Okay, so there are a lot of things you can do with the tshark out of the box. Also, you can add options on the command line. You can do that with Wireshark also. And as you can see, it will automatically save the configuration, but tshark does not. So that's a big difference. And to avoid different settings in your analysis, you can use either a different profile or use a different system. For instance, that's what I do. I usually run my analysis on a separate Linux server and do my manual work on a workstation. That's so we're using a Linux server workstation is faster anyway. So that's better. Next. So if you can open this Menti, then I can figure out what systems are you using or would like to know. Tali, can you share the link in the chat?
Yes, it's shared.
Okay, thank you. Then
No
let's see. Okay. At the moment, the majority is Windows. Let's run it for a while. I'm also doing this presentation on Windows, so that should be okay. Are there, in the meantime, any questions? Sorry. Nope.
So far, not yet.
Not yet. Yeah. Okay. It's also the beginning and start, so I would be surprised if there were any actually. Okay. Let's move on. So the majority here is Windows. There's 25% Linux. That's more than expected actually, and less using macOS. Okay. Let's continue. Move this away. Thank you for sharing your results. So next to tshark, there are a lot of command line tools which gets installed when you install Wireshark. And when I do my training sessions, I notice that a lot of people do know Wireshark, but don't know that there are command line tools like this. We can go over them for now. Let's go to the directory where it's installed. And let's do it like this. And it's installed in the program files directory in Wireshark. If you do that, you'll see that next to the, let's zoom in. Next to the executables, there's also an HTML file. So here you see tshark, textile pcap, reorder cap, and so a lot of tools in the directory where Wireshark is installed. And then you can use the if you add this directory to your path, you can use this directly. I believe it works out of the box for Linux and I think also for macOS, but I'm not quite sure about that. And if you go out by the tools you have in the front, let's sort it by type. Just a moment. You've got the cap infos. This is basically the same information you get if you use the information in the tab. It's like this, cap infos, and file. Then you can see the output, basically the same. Oh, by the way, you can also shorten the output of, let's say we want only to see the beginning and the end. and then you get only the select information, and you can use that to rename the files or whatever. Also in there is a tool called dump cap. This one. That's the one that does actual capturing. So if you click on capture in Wireshark or use tshark for capturing. Moment. Next slide. So if you use Wireshark or tshark, then it actually calls dump cap for the actual capturing. Well, for Wireshark, that's okay, but if you're working on the command line anyway, so when using tshark, that's probably a better idea to call dump cap directly. Also, if you want to do long-running captures, that's the better way to do that. And the capturing tool, use the capture filter, and the capture filter is sent to the driver or the actual capturing. And we can use the display filter or the read filter. Oh yeah, I can show the read filter right away. But you probably have noticed that before. If you go to Wireshark and say open, then here, here is a read filter. I think that is one of the least used features of Wireshark. But in case of tshark, it could be useful. It means that you're filtering upfront or not later. I can quickly give a demo for that. So here, let's go back. Here we do the display filter, which is after reading the file, and you can change that into a read filter. If I do this, you get an error because that has to do 2 passes. So if you add a 2 to it, I'll do this. You can now see it outputs 20 packages instead of the few before. Oh. What happened? Back to it. I lost control. Let's do it again. So if you use only this one, then sorry, one. Now you see that it only outputs 4. And if I change it to the read filter, it will actually change this to 20, because when you use the read filter, the package gets renumbered. So if you want to output only exactly 1, you can do that by changing this to 1, and it will only output 1, regardless the position in the file. Or none if it's not present, of course. Another thing might be handy to know is, no, let's put that. There are other tools. One is called edit cap. You can use that to take a time frame out of your capture, or to split it, or to snap packets, or to convert it into another format, or deduplicate. And since version 3.0, you can also use it to insert your SSL key log file information. That one is quite handy, by the way, because then you can just share one file containing the secrets, so you can read the contents straight away. For instance, prepared to LS. There is, see that's there. You can split the files, you can merge them. There's also a tool called Wireshark, which is a bit strange tool, which is also used for reading from pipelines. I've never used that one. We got a reorder cap, and a tool called text to pcap, so you can convert an hex dump into a pcap file if you want to. Okay. So by default on Windows users, let's see what the score is now. Still is 60%. Windows users online here. When you use the installer, the path is not set by the installer. In other words, if you go to the command line, it doesn't work. You cannot enter tshark or whatever or the other tools to start it up. Two ways to handle this, of course. You can either set it in the command, or if you fan of PowerShell, you can use this one to set it temporary. So you can just use it on the command line, and you can set it in the control panel for a permanent basis. And as always, you can also use the full path, but since the directory program files contains a space, you have to quote it, otherwise it won't work. But if you do that, and I've done it here on my machine, I'll start. Then you can run it from the command line. And also these help files are online, and Windows has a nice feature that if you enter the help file, it will open up in a different screen. Just a moment. There it is. It will open your help file, and you can read it offline, which is quite handy. This also works from the start menu, by the way. This is what I find more handy than using the manual page on. Oh, it didn't respond. Manual page tshark. As you can see here, it's exactly the same information, but yeah, I prefer the browser output because it's a bit more readable. By the way, on a Linux in the system, you can do that also. Locate tshark.html. Typo, just a moment. And there it is. And just launch a browser with this one. Oh, it took a while, sorry. And as you can see, it's exactly the same information. It's also the same information you can see online on wireshark.org/docs, I believe. And well, I prefer this way because now you can have it in a separate window next to your command window, or your terminal window, I should say, where you do your stuff. So that's a nice feature of Windows. Let's move this out of the way. Okay, let's. tshark has a lot of possible outputs. I will show you a few. This one you already saw, and this is basically the default for the print more or less. So if you use the option print, then it will show the same thing. And if you compare this to Wireshark, this output, the print output, is the same as the packet pane in Wireshark. You can also use the V option, and if you do that, it will output the same information as here in the packet tree pane with all expanded. It's the same information if you use the V option. Well, that's usually a bit too much, but you can also trim it down, and you can say capital O for output only, and let's say TLS. Then it only outputs the TLS data for that file. So that's some ways to control what's being output. And if you add the X option for the hex dump, then you'll, sorry. Then it will also output the hex dump pane, which is this one. But if you go to here, I will have to open another one. That's better. But in here you can see that's also outputting hex dumps of decrypted and decompressed. If you use the X option, that will be shown here also as 3 sections. Another nice feature of tshark is you can, and here in Wireshark you have all kinds of statistics, and you can do that also in tshark. For example, you can use the IO stats. 0 here means the interval of 0. In other words, I want the data of the whole file. You can select the columns you want to see, and you can specify which display filter it should be used, and then what you want to do. In this case, count or average, or whatever. You can see what the possibilities are, of course, in the online help. Somewhere down here. A lot of options. You can see the IO stats. I'm looking for the IO stats. As you can see, there's a lot of options. Yeah, this IO stat. You have to count. You got some minimum, maximum, average, or load average, and you have to supply the field where to apply this calculation on, and the display filter to select. So most of the time you will simply have to repeat the field and the filter name to do the statistics on that one. Okay, next, also have an option called capital T, and that allows you to give you different outputs, for instance, in a JSON format. Let's do that. Let's make the read filter. Sorry, output only one. T IFA. Oops. As you now can see, it's one big JSON. It's actually outputting one line per packet, which is nice for many tools. You don't have to add spaces. You can do that also. If you use the JSON option, then you'll see the same information, the same JSON, but now what I call pretty prints with spaces. And you can see here the name and the value, for example. But if you say I want the JSON wall, then it will exclude the names of the fields. As you can see, you now get a shortened version. Okay. I can also output it in XML. Okay. No. Well, that's just more of the same for me. And we already saw the text version, which, sorry, typo. The text version, that's the default setting. And you can also change it to tabs. Now it's in here, separated by spaces, one or more spaces. If you use tabs, then it's a bit more easy to process. You got the PS option to output it in PostScript format, and if you output it in PostScript, you can convert it to a PDF. And we have the fields options, and if you use the field options, then you have to specify what you want to see. Let's say range of number, for example. Let's do it like that. Oh. Fields, sorry. And you can see it outputs now only one thing. Of course, you cannot remember out of the top of your head what the fields are called. because there are over 200,000 fields in Wireshark. There's an easy trick. So let's say you want this field. You can here copy the field name. Can you see that? Field name here. Here it is. But for visibility, I will do prepare. Why isn't it selected? Prepare selected, and now you can see in top the header, the name you should use if you want to print that field. So that's the, especially if you just started, the easiest way to get some output. And there are some special ones. It's called _ws dot call and dot, let's say, info. This info has the label capital I info. And if I repeat it here, then it will use that one also. Oops. Calls. Typo. Is called info. Oh, I see it. Should be underscore. I said underscore, but apparently it didn't type it. And now you can see it has output the info column only. So this way you can control the output, and this is handy for post-processing the output of tshark into your own automation tools. Okay. And there are many more options. And you can also go back here, control the fields. Let's say want to show the IPv6 address. Do it like this. Yes. IP address. Okay, different file. Sorry. And you can see here now there's a comma in between, and that means that there are two fields that confirm this to this filter, and that is of course the source and destination address. If you don't want to be comma separated, you can specify that by using the capital E options and say separate. Well, let's say semicolon. Up, typo. And now you can see the columns are now separated by semicolon. You can also change this one. And you can say if you want to have a header edit. For output also headers, exactly, etc. All exact settings you can find in the help file. Let's leave it like that. Okay. I show you the TLT fields options, and there is some issue with that, because it's not related to how do you say it? There's no history, so I show you what I mean. So let's go over this command line. Well, open here the file. Read the file, and we want to output only the TLS layer and do it read filter. Shake. Type 11 is the certificate. This means I want to output the TLS information, and I want only the first certificate, right? Let's grab it for 4 lines, or not B4. So what you now see is 2 fields which has the same subfields, but it can also be there it is. There are 2 types in that field that can be used there. So you can also have a generalized type. So if you supply the this is what I showed you. The generalized type is of a different field name than the UTC time. UTC time is valid from 1950 to 2049. So anything outside that must use the generalized type. But if you use the fields for that, you won't be able to tell to which is before or which is after, because it can be mixed in the output. There is no hierarchy when you output that field. Something to remember that if you want to use that one. Okay. Well, let's go for a practical example. Let's generate the host files from the PCAP file itself, because reverse lookups may not provide useful information anymore, either because the website is hosted in the cloud, so when you do a reverse lookup, you get a very strange name, or dynamic DNS is used and the names has been changed between the time you captured it and between the time you started analyzing. For the old days, website using multiple website used hosted on one server / one IP address. So what can we do? We can get the files out of the host file, out of the PCAP file itself, and generate our host file. Let's do that. Let's first show you how you can get it. Oops. Very good. I want to do is use this one. If you don't, so you can have the output here. Let's filter it on http.host. Sorry about that. So you can find that filter in your files. Let's show it in Wireshark. Use the same file here. If you go to HTTP GET here you're on the host file, and zoom in a bit. This entry combined with the destination address, it's like a 6 address, by the way. These two, if you combine these two, then you get an entry you can use in your host file. And you can use that for the HTTP, but you can also use it for the TLS level layer in the client hello. Here you can see a server name. We'll prepare. There you can see it also. Name. You can use that one, the server name identifier, to look that one up. Okay. And if you continue and you can output this information like this. Just a moment. And you can see the two names outputted like here. One is captured from the HTTP request and one is captured from the TLS client hello. And you can use the sort options using the options U for unique to deduplicate and I to ignore spaces, and then you get only 2 entries, which you can then add to tshark using the -H option. So if you store this one, then you can use that one in tshark to import, use that host file like this, H host of text, right? And now it will use that name wherever it finds it. Another way to do is you can store it, new file, new, and then we have to use the option W and for network, and then it will create a new file containing these hosts in that file. And if you open it up in the Wireshark, for new, you will see that it uses this host here. Oops, as you can see here, right? And there are a few more protocols that can do that. Now it goes. You can also do it for the quick protocol. You can also do it for DHCP. All these 4, the client side will send the name it thinks it's talking to in the handshake. But to limit the output that you don't get blank lines, or better, lines with only tabs, because if the field is not present, it will not fill it, but it will still get separated by tabs by default. We use the display filter here. Okay. And then you can output it. I showed you. You can reopen it in the store it in a bigger file, like I showed you. Okay. Okay, let's go for a more practical example. I have to speed up, I think. For analysis, it's usually best to have complete TCP sessions. I think in case of a protocol that uses TCP, which is the most of them. And so you want to filter out all incomplete streams, which are typically at the beginning or the end to capture. Now, let's start simple. Let's start with only the start of the capture of the session, TCP stream. And you want to filter out any streams which has no TCP SYN packet. The way you can do that is you can output the TCP stream and filter it on the SYN flag set and use that output for as input for the next tshark to create a new file. Let's go over that one. So let's do it simple first. Just copy paste it to speed it up a bit. So if you got it like this, you got a file, it's got 3 streams that contains a SYN packet. And here you see 2, one for the SYN and one for the SYNAC. Let's show you. Let's see. Underscore call. Oh. can see here, you got the sin and the syntax. Is that a bad thing? No. It could be more than 2, of course, if you've got retransmissions, and you can also have 1 if you happen to miss the initial sin. That's not really a problem. You can sort it like this. Now you got 3 things, and we can store it into a variable. I do it in 2 steps now for readability, like this. And to show you what stored. Like this. And then you can use this output to create the new file by using this output variable. Oh yeah, that's because I'm using Windows. I'm using Sigmund here, which is in the terminal Warner-Guess shell on Windows, but it calls the Windows native tshark, so the output contains characters and line feeds. So it was the Linux. Do it again. Now it will work, and I can open this file. Like this, and it will now only have the 1, 2, 3. If I sort it on TCP stream, you see only 3 left. Okay, that's a way to filter out incomplete streams. Okay, next step. What you want to have is a complete stream. So from TCP SYN to fin or reset. The logic we'll use, we use the stream number as an index, we record the SYN packet, and record the fin or reset. And in the end, you output the ones that match the criteria. So to capture all 3. What I've done here, I outputted TCP stream, and I outputted the SYN flag. So what you can see, sometimes the SYN flag is present, sometimes it's not, meaning that it's either fin or reset. I'll show you. If you go to Wireshark and go to the TCP layer flags, I use here a Boolean and 7. 7 means the lower 3 bits set. And guess what? The lower 3 bits are fin, SYN, and reset. So that's the way you filter on those 3. There's one way to do it anyway. Okay, so this output we can use in our application. Let's use walk. We know it's tab separated, so let's have the tab separated. And for each packet, if the second value is set, then store the stream number. Oops. Let's see. And otherwise, if you see a reset or a fin, you want to mark it as a complete session. Or 1, 2, like this. And finally, you want to output that one. I'll copy paste it to speed it up a bit. So yeah, you go through the loop and everything that matches you print out. And then have a syntax error. So now you have these fields again, but you know for sure it's only a complete session from the beginning from the end. And you can use the same method to create a new file only containing these complete streams. Yes. Oh, and by the way, by storing it in this way, you don't have to sort output. And depending on the program language, bitwise OR would be faster than what I just did in OR. So this is how we did it. Okay. So as, one thing to note is that you have to provide all the information for tshark on a command line. So if you generate filters like that, it can grow big very fast, especially if you have big files with, say, thousands of TCP connections. Then the filter can go quite fast. If you go work on a Linux machine, then the command line can be about 2 megabytes. For macOS, it's in the order of 265 kilobyte. And the Windows is the smallest. You can have 32K on PowerShell. And if you use commands, it's even smaller. So that's something you have to keep in mind. And sometimes you have to optimize your queries. Also, a compiled capture filter has also a limit, which is 1 memory page of 4 kilobytes. So if you're using dump capturing or TCP dump for any capture filtering type, there's also a limit over there. So, okay. But you can optimize it by using the stream operator. And it's this double dot. I'll go a bit faster. The trick is you go through through the array, and for every match you find, you determine if there is a range, or look for the first gap. And if the range is the length of the range is larger than 3 or equal, then you can use the range operator. Okay. So if you do that, the logic is the same. You can see here. I won't show you because of the time. You loop through the results. If it's a match, then you look for the end of the range, and if so, you output it as a range, etc. Okay. Other questions so far, by the way? Tali.
Not yet, but
okay.
we can invite people to ask questions if they want.
Okay. Would you go all back to the Menti and answer the question, what operating system are you using? Okay. So it's still on the, what's your preferred programming language? I would like to know that. Is it still working? It comes in. So the first response is Python. Python is an interpreted language, by the way, which is not really an issue because just I used awk and it's also interpreted. Typically, most of the work is done by tshark, and what you're doing is relatively easy. So I also see Perl assembly. Go language is a nice language for multi-threading. I don't see Java. Nobody using Java? No. Python is nice if you want to use the JSON output of tshark. Okay, thank you for responding. Let's continue. So normally what we do is we use the output of tshark to read into your own program to do a additional analysis. Some of you said C. Well, for that you can use the good old popen. It stands for popen, pipe open. You want to be on the receiving end for reading output. For guys who use Go, yes, this command function to read output of tshark. Perl, you use this indicate to indicate you want to use pipe to read the output. What's the Python also? Yes, that is called sub process popen again for pipe open, etc. So most of the time we're using pipes for reading the output. If you use pipes, by the way, then the outputs get buffered. So typically a buffer is 64K on most machines. So let me see. Normally the output to the terminal is line buffered, and for standard error it's unbuffered. I can demonstrate that. Print. So basically, is it readable? Zoom in a bit. So when I type something here, it will echo it back when I hit enter. You can see that, right? So this one is line buffered, Ctrl-V. But if I use a pipeline, then it gets fully buffered. So when I type something in, you don't see the output because it's now buffered. And only when I do Ctrl-E to end file, you get the echo. That's because it's buffering. Is that bad for tshark? No, usually not, because most of the time it slurps in the data in memory, that does its filtering, and then starts outputting. So the time it starts outputting, it's always quite fast. But if you want to, you can force tshark to output it on a line-by-line basis, or to be exact, on a packet-by-packet basis. It's the option -L. I don't see it now. Where is it? There it is. As you can see, you can force it to flush the output after each packet. This is pretty much only useful if you do live capturing. Otherwise, don't use it. It's not really optimizing your output, right? Okay. Also, if you want to do analysis on your own, you can make your life simpler for you if you can process it stream by stream. So if you can, if you have a capture file, let's pick one. You see these streams intervened, interleaved. What's the name? But if you can also sort it, and then way can process it stream by stream. I'll show you how to do that. Let's open here. So let's just pick a file, and fields, say this in here also. The one. I'm going to put the TCP stream, and let's say the time. Okay. So what you got here is the stream number in front and the time in epoch time. For post-processing, it's easier to have it in machine time than in human readable, because then you have to convert it back to machine time to do some fancy things. And for this, we can add some extra information. Let's say IT.source. And yeah, now you'll see it outputs this one. Now, this output, we can now sort like this. As you can see, let's make it a bigger file. And as you can see, it's now sorted. You get the first stream first, then it switches to the next one, and the third one, etc. By the way, I did sort it without any options. That means that the whole line is treated as a single character array, character string, and that works because here you only have to detect the change for the stream number, and the epoch time. Well, it will take at least 7 years for the next rollover for in case of a 32-bit version, this the PCAP, and the PCAP NG, it takes over 200 years before you get the next digit. So, but you can force it to use the numbered version, the numbered sorting. I'll do it like this. Now you force it to sort it numerically on the first two, and the output is in this case the same.
Andre, do you want to take a question?
Yes, the question?
Yeah, so there is a question from...
Oh, it's a bit off topic about the bash shell, right?
Yeah.
What I'm using here is called Sigwin. You can go to sigwin.com. Let's quickly here. You can install from here, and then you can use the bash shell straight away from the command line. I use this because I use a lot of Linux servers, a lot of other systems, and having the same shell on all my machines makes life a lot easier. I don't have to reinvent your scripting. There's also a gotcha because now we're on topic. We got this environment variable called time zone, which is different from Linux than Windows understands. Let's do a little. So if you, oh yeah, got one. So you can see here the time here gets mixed up. If the time zone is not set correctly, I can show you like this. Then it will pass the TZ variable on to the Windows executable. So the trick is to make sure that the time zone variable is not set. If you do that, then it will give you the correct time. Okay, back to the streams. Oh, I just told you that, and then you can have this output. Looking at the time, yes. Okay, there were also people using Perl. Let's go for Perl. Normally, you would use here an array to specify a command, and here I'm using a string. That's if you do that, then it will use a shell to launch a command in between. But I do that because I want both tshark and sort command executed and only the output of the sort command in my loop. And in your while loop, you can then read the output you just specified. That's the benefit of using these field options. And in Perl, you can give it a nice name to process it further. Yes, and you can recognize a new stream by change of the first column, TCP stream number, and you can do then some post processing or resetting counters for the next stream, etc. If you run this script like this, I will give you this output. I'll show you. Show the output of the script itself. Okay. And here, oh, zoom in. Here we have this example I just showed you. And here I do some processing. And when I call this function, it outputs the time. As you can see, the input was an epoch time, but we can output it in any format we want to using the functions to do that. Okay, and you can do your own pre and post process. So that's just the basic concept of processing the output of tshark into your own tooling. Okay, another nice, well, you can do a lot of processing you can think of. One that most people don't think of is called data after TCP SYN or reset. TCP protocol itself allows you to have a half-open connection, meaning you can send a TCP FIN, then you can no longer send data, but you can still receive one, and vice versa. If you cannot respond if you're close to a session. So that's not useful for most applications, or practically all. So in practice, half-open connections are not used, right? So when they are used, or when you do see it in your PCAP and your network capture, then it's a strong indication that something went wrong, not on the network level, but on the application level, right? So that's a nice thing to look for. There's one exception, which is the so-called TLS alert, because it sends close notify, and then closes the TCP stream, and you get close notify back from the other end. I can show you here. Here you can see it. I have to remove the filter. You can see it. Let's just filter it out. Oh, it's the wrong one. You can see it sends an alert, sends a pin. Then from the other end, you should receive a close note also, not in this example. Anyway, so normally half-open connections indicates there's a problem. And why is that? It can be because of so-called slow backend. So what you can see here in the front end, you have a client that sends HTTP request after doing the TLS setup. That server or microserver or whatever sets up a backend call to gather extra information. Normally get answer, and that allows him to send response to the client. But what happens if this backend is slow? Well, if the client times out or is terminated or whatever, then the connection gets closed. We'll see in the capture a close notify. But if the server does not respond to that and keeps waiting for the backend, and what you see now is that it will send forward the response and then respond to the closure. But by then the client is already gone, closed the connection or closed the socket or was crashed, killed, whatever. And then the operating system will send TCP resets. So you see here, you have a TLS close followed by data, indicating a problem. Other reasons it could be, of course, that there is a small time delay and the round trip time. That's normally not the case. So how do you catch that one? Well, for every packet, look for the fin or reset. If that's present, mark the close started phase. Then the next packet, if the length is greater than 0, so there is data on TCP level, and the close started and it's not an alert, then mark that it is data after a fin or reset. And if you want to, you can exclude the time between round trip times, just to be sure. In practice, that's not really necessary. And when the TCP streams changed in the data, then you know where you've really finished, and then you can issue a warning or a critical message that something went wrong here. Okay. Okay. No questions so far? No more questions? Okay.
Not yet. If anyone wants to ask, we have just a few minutes left, so now is the chance.
Yes, oh, I've got time. Okay, so for me, it changed from handy scripts to fully automated tooling, allowing novice users to upload a PCAP file and get a report generated. And it's also used as part of performance load testing to see if everything is working as it should be. Because sometimes the application builder doesn't see, especially the TLS layer, if his change has bad consequences on performance. Okay, so this is why we automated. We needed faster feedback. The trick we do is we upload a PCAP file to the automated system. We use a sanity check to see if the file is correct. You don't want corrupted files or too many snap packets or low volume. What we do next is we split the files up into known protocols. So you don't have to supply a huge filters on your command line every time. And also makes life easier and faster. Small files will be processed faster than big files. And then you can process all the applications and protocols you found and you generate a report. Looks a bit like this. Okay. Oh, sorry, one. Okay, now let's skip it. So this is an example of how you can check for invalid files. You can run the tshark command, read the file. We want no output, only the statistics, and no network translation, address translation, etc. You can look for problems. By the way, if you do capturing on virtual machines, you may see negative delta times, and that has to do with the way the data is captured from the incoming and outgoing data that's done on different levels. So if you see negative delta times, then it's probably a ring buffer overrun occurred in the kernel, and you can take it like this. And for a IO stats, you can process it by looking for the data. Okay, split 15 minutes, yes. Like I said, splitting up into known protocols makes life a lot easier. For instance, if you see a web server running on a high port number, then maybe an issue, but you can also look at the data, what's being sent, and say, okay, that's a Splunk agent and not a normal web server, for instance. So you can go from more specific to less specific filters to split them up into known protocols. So and you create a new file using the not filter, the exclude filter, and then you can go through the whole file again and again. It gets smaller and smaller, and what's left in the final is the ones you don't recognize. Okay. Network capture should, for statistical analysis, should contain enough data. So at least 5 minutes is my advice, and not pre-filtered. So if you use capture filters in the wrong way, you won't see the problem. Give an example. What really happened is that there was an application, there was some web service basically. They captured the traffic of the application, and they could not figure out